Now, ready? That's okay. One of the most important ones is raised to the power. When your exponent is your variable, the only way to bring that exponent down is with your power rule. The only guy that owns that power rule is a log rule. So we have to use a log power rule to bring down this exponent. There's no log words here. So this is the time where we give logs to both sides. Whatever you do to one side, you do to the other side. Just like you have a regular, just like you have a regular equation. If you divide one side, you divide the other side. If you multiply one side, you multiply the other side of the equation. So because this is base E, we have to use ln. So we put ln on both sides. We give logs to both sides. We give logs to both sides. We take logs away from both sides. Now, if you remember your property, your ln E cancels out. This cancels out and says x is equal to ln 72. Now, all you have to do is put that in your calculator. Good morning. Let me give you your schedule. Okay, now put that in your calculator and round to 3 decimals for me. Brianna, don't worry about it. I don't worry about it. So put this in your calc and round to 3 decimals. As with any equation, it is self-checking. So you can absolutely check this. You can raise e to the 4.277 and you will approximately get 72. You won't get 72 exactly because we rounded. If you do the second answer thing before you round, you will exactly get 72. But if you're close enough in the rounding, that's fine. So they're nice to check. So whenever we have an exponent as a variable, you need to use your power log rule. That will bring that down. Now, we could absolutely bring this down like this first, and then cancel out the ln E. I just kind of skipped over that step. You bring your power down, and ln E cancels out. That's the property for itself. Remember, e to the x is e to the x. It's the same property. Okay. I want to hit as many as we can here in our short little time. Okay. Again, we have a variable in the exponent. We need to use your power rule. We can't use your power rule unless we have logs there. We can't put logs unless it's one term. So what you need to do is get it down to one term. Isolate this term. Subtract 5 from both sides. No different than the last one. We just need to isolate this first. And you don't have this. Anybody else just walked in? Right? Oh, Amber? Okay. So now you put logs on both sides. Let's use your power rule, bring this down. This cancels out. We've got x is equal to ln 55. If you were looking for an exact value is this. You can't go any more further than that. Same thing like with the radical. If you get radical 7, you can't reduce it any more than that. So exact value would be radical 7. In this case, your exact value would be ln 55. If we're just rounding, then you put it in your calc, and you round to 3 decimal places. Our rule of thumb is still 3 decimal places. If I ask you for exact value, ln 55. Good so far? Okay, let's add one little step to this. God bless. This is one term, one term. Again, I have a variable in my exponent. I need my power rule to bring it down. So again, it's base E. So we're going to ln both sides. Okay? Now what do you notice? I had one term, one term. I need to bring that power rule down, but where does that exponent belong? To the E, right? What's it being multiplied by? 4. What does my product rule say to do? Add. Grab one of these right here, too. Then I have your schedule for your new semester. Don't worry about signing in. Okay, now I need to bring down my power rule. This guy needs to come down. Just follow it step by step. This was your product rule. You might not remember this because we haven't done this probably in almost 2 weeks. It'll give you a good chance to digest all this. This is your property. Out this comes. We need to isolate your x, your variable. So subtract ln 4. Now be careful. You can't do ln 5 minus ln 4 and get ln 1. This ln 5 belongs here, this belongs here. So you have to do it this way. And then divide by 2. Remember to put this in parentheses. And then you're going to solve for x, and you're going to get 3 decimals. And again, you can check it. It's an equation. You can check it. So we had to bring down your variable. If we bring down your variable, we need the power log that it was multiplied. Remember, one of the things that I always find is kids forget that this only belongs to this guy, not to that one. So separate that product. When we multiplied like bases, we added the exponents, separated into an add, and just follow it like a regular equation. This probably is one of the more important things. If you do ln E on your calculator, it comes out to 1. So that's your property. That kind of helps if you're doing this property. Questions on this? Whenever you have base E, you have to use the ln. Any other base, it doesn't matter, but you have to use ln for E. Okay. Now, this guy has a log in it, but it only has a log in one term. So we're going to have to isolate. We're going to have to isolate that ln, because if you can get it down to log equals something, then you can flip that to an exponential equation. You will not be able to cancel it out, but you can take that and turn it into an exponential equation. So we have to isolate this. Now, where do you think this 2 came from? Exponent. So the first thing we're going to do is bring up that exponent. Now we need to isolate the ln. So subtract 5. You need to isolate this first before you can do anything else. Now, you can't take this log away because it's only a log on one side. You can't add a log to the other side because you have to do the same to both. But it is the same as if I did this. Flip it to an exponential equation. Log equals exponent. The base of your log, the exponent. So we're going to do the same thing here. Log equals exponent. Log and ln are the same thing. So the base here is E. The base is E. The base in your log, if it's not there, is 10. E to the negative 1 equals x squared. And if you want to do this all at once, you can just take the square root of these guys. Take the square root When you take a square root, you get a positive and negative. But remember, you can't have a negative in your log. Your log goes like this. Your domain, God bless you. Your domain for your log is from 0 to infinity. So this guy's going to give you a plus or minus. Let me look it up. Okay. But you cannot use the negative. You can only use the positive side. Your goal is to isolate the log. In this case, isolate ln. Okay? We can't take it away because it's not on both sides. We can't add it to the other side because we have to do it to both sides. But when you have a log on one side, your goal is to flip this to an exponential equation. Remember the base for ln is e. Remember the base for a log is 10 if it's not there. And in this case, remember your domain for your logs, or ln, is from 0 to infinity. Okay, we got one more to try here. One more type that you're going to see. Kind of have logs all over the place. So your goal is to get it to be log equals log, whether it says log or ln, it doesn't matter. It works the same. First thing through, look for anything in front of your ln. There's a 2. Where does that go? Exponent. Good. Remember backing out of your equations? Now, I can't take my logs away until I have one term equals one term. So I have to use one rule to bring this down to one statement. Multiply. When I was adding the exponents, I was multiplying the bases. So this is your product rule. You might want to go over those rules again since it was quite a while since we kind of looked at them. Bring this down to a product. Just kind of leave it like that when we start. Now, this is still on your left-hand side, one term. It's got 2 factors in it, that's okay, but it's still one term. Now, you can eliminate the ln. You put logs on both sides, you take logs away from both sides, but they have to be one term equals one term. And then you're left like this. And now we have to solve. I'll just take a shortcut. We distribute this guy. We get everything to one side. We factor. Oops. That's x minus 1. Okay? Now, we find our result. However, you need to check because you cannot take a log of a 0 or a negative number. So you have to bring this x back into these and make sure that nothing becomes 0 or negative. If I put the 6, I'm okay. If I put a 1 in here, I'm taking the ln of a negative number. Can't do that. So this is a reject. So your solution is just one answer. So these are all the types you're going to see. So try the homework. You have 2 days. You have 2 days till we meet again. 4, 5, 6, 7.
4, 5, 6, 7.
4, 4,